the first one to click is the one which is next to the faulty node.
I know, but what I was trying to say is that you are using negative acknowledgement, which means that you did not receive the packet. So
No, you did not receive anything. You did not receive. No. You don't just do. You could be malicious.
But if I'm malicious and I say that I did not receive, I can actually put the blame on innocent.
That's correct. And what it happens, this is suicide. You kill yourself and the next one. So a malicious node can commit suicide in order to kill the one downstream. So anybody can do it. I said the one of the two is malicious. I still win. The system wins whenever a malicious node, if a malicious node signs such a document, then it's a report, then the system wins, the adversary loses. Because the adversary, if it's one-to-one, the system wins on a one-to, if the system can exchange a good one for a bad one, then the system wins. We can talk to it offline. It's an interesting protocol. The next one is, I haven't got much time. And so what I wanted to point out, and I'll quickly do it here, is that this can easily be piggybacked, can be linked with existing protocols which do not offer the service. So AODV and DSR will certainly work in this way. So you just have to add it, and so you get the security, the reliability which AODV or DSR offered, plus the security in the sense that either the packet will be delivered or somebody will be traced. Possibly a malicious, a faulty node which just wants to cause problems. But if you capture a faulty node, that's good enough. I will quickly want to go over this adaptive multipath routing because it is interesting, and I think 5:20 is my deadline. So I'll take 5 minutes. So the question is this. It has been long sort of accepted that if you could send your messages over several paths, then if one fails, you have some backup. And this has been a good way of dealing it, but reliable. But except it's approaching the spirit of flooding. Flooding does this in a sort of more complicated way, but it does too much of it. It has too much sort of redundancy. So if you could control the redundancy, maybe if not all broadcasts are part of it, but just those on vertex disjoint paths, maybe you can do better. All of the multipath routing algorithms are algorithms which find paths, several paths, and usually you just choose the first one. And after that, you dump all the others. What you do here is you don't. You continue and you build it up. But then what you do is when you broadcast, you use the first path you got. So adaptive multipath routing is actually single path routing to start off with. The adaptive part comes with the enemy, provokes you. So if the enemy disrupts your path, then what you do is you pull out of the bag the backup paths you have, and you use a backup path. So you have all the others, but you don't use them. You use the first one, which is also the shortest one. The other ones are not used. They are only used if need comes, if there is a need. And the system this protocol is designed to adaptively, during time, change this and always come up with paths. And it builds up to a maximum size of paths. And the best application is the round-robin one. So you have all your paths, which are vertex disjoint, at least from the view of the honest nodes. And what you do is you send and you have many packets to send. This is and you send each packet in a round-robin way on the next available path. And if some is sort of broken, then you use it on the next one. And so essentially the cost is the same as single routing, except that you have to find multiple paths. But the approach for multiples, once you trigger an approach for a single path, more or less automatically you get side information for further paths, which usually you dump, and here you don't dump. So I think what I will do is I'll give to Christina the paper and you post it. Is there a web page? To post it, and because it is interesting. There's a lot of discussion here. It has certain nice properties. One of the nicest properties is that actually it can also be piggybacked on existing routing algorithms. So, for example, or it can be combined with the tracing algorithm, so you can get that as well. It can be combined with DSR to get a sort of adaptive DSR. So DSR also finds some more paths, and you can use the more paths. And that's it. Thanks for your patience. Please, yeah, I wanted, yeah, go ahead.
Yeah,